back to my channel. My name is Anna, 10 Pencil, and I am on day 18 for the Juleetcode, July LeetCode challenge. I'm doing my solutions in Python, and as you can see, I have been working on this problem for the last 50 minutes and forgot to record. So, I also have JoJo here with me, and she has been such a help. I can say hi. Hi, JoJo. Say hi, JoJo. She's going to the vet tomorrow. She's getting some shots. So yeah, I just ran this, but I kind of wanted to go through pretty quick, and you can see I haven't submitted yet. Go through the question, and then kind of go through what I did loosely, so I don't take up too much time explaining it, because it is 11:33, and I do have to be up early for her vet appointment. So, without further ado, day 18 is question number 146, LRU cache. So design a data structure that follows the constraints of a least recently used cache. Implement the LRU cache class, RLU cache into capacity. Initialize the LRU cache with a positive size capacity. Int get, return the value of the key if the key exists, otherwise return -1. Void put, update the value of the key if the key exists, otherwise add the key value pair to the cache. If the number of keys exceeds the capacity from this operation, evict at least one of the recently used keys. The functions get and put must each run in a 0-1 average time complexity, and then they give you the examples, or the example rather, and then the constraints down below. So this wasn't what it looked like originally. Let me copy this really quick so you can see what it looked like at the very beginning, because it looks a little different. Yes, I know. Be really sad. Okay, so this is what they give you right in the beginning here, and then this is what I was able to put in to these spots. So in the init method, we initialize this LRU cache with the given capacity. So we had an empty cache dictionary to store the key value pairs. And an empty list that we called order, basically just to maintain the order of the keys. So when we go down into this get method, we just check to see if the key exists in the cache. And if it does, if it does, then we remove the key from the order, and then add it to mark as recently used. And then we return the corresponding value to the key, but if we don't get it, then we return -1 as we have here. And then down here we have the put method. We first check to see that the key already exists in the cache. And if it does, same kind of thing, we remove it from the order. There's something on me. If the order's list length exceeds the capacity, then we just go ahead and remove the least recently used key, like key value pair rather, from the cache. And then we add the new key value pair. So we mark it as recently used. That's basically the low breakdown of this here. So this just does a dictionary, and then lists. We have our get method here, and then our put method. And when we run it, she is fine. So after 54 minutes, I'm actually very excited to submit this and see how I stack up against everyone. Hopefully. Okay, so my memory is rock solid, but my runtime is trash. For lack of a better term, my runtime is trash. So definitely some stuff I need to work on, as per usual. The editorial for this is only for premium users, so if you have a chance, this is one editorial I actually would have sat through and read because I did struggle with this just a tiny bit. But 54 minutes, 57 seconds. I beat 97% of users in terms of memory with Python, but my runtime was abysmal. So I will put this code in my GitHub repo, which is going to be in the in the video description down below. You guys are more than welcome to fork and clone it. I will leave it up to you all. If you can make it better, make it better. If you can't, then that's fine. Hopefully you learned something, had a little bit of fun trying to do this stuff. So anyway, thank you guys so much for watching, and also maybe check out other solutions too, because I don't think this is obviously this is not the best solution, but yeah, thank you guys so much for watching, and I will see you guys in the next video. Goodbye.